Hi, ladies and gentlemen. Welcome to Graphing for Biology Made Easy by me, Mr. Chan. And I will be guiding you through the main ideas for this part of the presentation. Hope you guys will be able to learn something from it and use it well. As you know, in O levels, more and more questions are coming out based on application questions, things that require you to plot a graph, analyze a graph. So this online lesson is mainly to cover these two sections. Now, what is the purpose for graphing? Graphing is actually a very powerful tool to put data, lots of data, numbers into a diagram. And from this translation of numbers to diagrams, you can actually look for trends. If something is increasing or decreasing, be it rate or be it whatever relationship between the two axes. And at the same time, you are able to use it to predict values. Values predict data for those experiments that you do not do. For example, if you do an experiment with rate versus, say, the temperature of an enzyme, and you can actually use a graph to predict those temperatures which you did not carry out, and it could be fairly accurate. So today we're going to just go through the two main sections. One is how to graph, and the other part will be analyzing graphs, especially for O-level questions. Now, how to graph? The first thing is to understand what goes where. Of course, we need to first identify which is the x-axis. Now, the x-axis is where the independent variable is, which is actually the variable that you design or you set or you change in an experiment. And of course, the other axis will be your y-axis, and that is your dependent variable, which of course is the result that you get. So the x-axis is what you set, what you do, what you change physically in the experiment, and the y-axis is what results you get. So a very good example will be in the tests. We did temperature or pH versus the rate of enzyme action. So if you change the temperature, that will be the independent variable, and the rate that you measure will be the dependent variable. The second thing to think about will be definitely scaling. Now, scaling means to actually put the graph, maximize the space on the graph paper. So for scaling, first thing is you must calculate the range for both axes. So for the x and for the y, and from then, understanding and knowing how big the graph has to be, you're gonna put this on the piece of the graph paper or the space that's given to you, and that's how you make it occupy most of the space. Now, this is a work example that I want to go through. It's quite a fairly simple experiment, and it's not really real. It's all with fake data, but I just want to use it to go through certain points. So for one, always when you see a table, now most of the time graphing, be it in an exam or for SPA, the data will either be, of course, in an exam the data will be given to you, but in SPA the data will be what you record. So this example is changing the pH of a solution and then measuring the time taken for, say, an enzyme to digest maybe starch. So we're using this example. Now, the first thing, of course, is to identify which is the x-axis. And in this case, the x-axis, of course, is the pH of the solution, because that is the one that you vary, that's the one that you change. And the y-axis will definitely be the time taken, because that is the data that you measure. So understanding that x-axis is the pH of solution and y-axis is the time taken will be the first step to constructing a graph. The second thing, of course, is to find out what is the range of the graph, the scaling of the graph. Now, for the x-axis, the scaling is from 1 to 14, so you need actually about 14 squares, right? So if you just take the maximum number minus the minimum number plus 1, or plus the unit that it's in. So this is usually, this will be 14. And of course, for the y-axis, the maximum is 110 and the minimum is 10. So that still is also, so you need about 110 squares. So using that, okay, so the x-axis will be 14, the y-axis will be 110. You put that on a graph paper. So looking at a graph paper, as you know, this is a sample graph paper attached on the right of the table. At the bottom, the x-axis, I think I last counted was about 9. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Okay, so if it's 9, you know definitely you can't fit every one big square for one unit, so you have to do it 2. For the y-axis, I think I last counted was 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can actually squeeze the whole range on it for the y-axis. So this is what it will look like when you plot the axis, right? So those are the things that you need to first set up, right? So the axis, the scaling, so that you occupy the entire space.